Alright, so we're starting out with a series of videos on exponents, and we'll start with I can multiply powers that have the same base. Through the course of the videos, we're going to establish some rules for us to follow when we're dealing with exponents. And so if you watch them in sequence, you'll see all of the rules that apply in these situations. So let's start with powers to power. So I'm going to sort of make up an example here for just a moment so we can see what happens when we multiply exponents. So we'll take x to the third, and we'll multiply it by x to the fourth. You'll see here first that these two expressions both have the same base, the base being the x in both cases. And then they have an exponent. The first one has an exponent of 3, and the second being an exponent of 4. Remember that exponents are really just fast ways of writing multiplication. So when we write x to the third, what we're really writing is x times x times x. And when we write x to the fourth, what we're really writing is x times x times x times x. When we multiply all of these together, we have 1, 2, 3, 4, 5, 6, 7 x's multiplied together. And so we can rewrite that in its shortened form being x to the 7th. Now we don't want to have to write out these products every single time in their expanded form. So instead, what we can notice is that x to the third times x to the fourth, if we take the 3 and the 4 and we add them together, we get x to the 7th. Notice 3 plus 4 is 7. So that's a nice little shortcut for us, and we'll call that rule number 1 of exponents. When we multiply powers, with the same base, we will add the exponents. Let's see how that rule applies to the problems below. In problem number 1, we have x squared times x to the 5th. They have the same base, both being x. So we can take those exponents and add them together. 2 plus 5 is 7, and so the answer for number 1 is x to the 7th. For problem number 2, we have y to the 4th times y to the 1st. Remember that if there is no exponent, then we assume that there is an exponent of 1, times y to the 7th. They all have the same base being y, and so we can just add the exponents. 4 plus 1 plus 7 gives us y to the 12th. Problem number 3, the same base, both being m, so we can take the exponents and add them together. 3 plus 8 gives us m to the 11th. For problem number 4, we've got many different variables with different exponents. So again, we can multiply anything that has the same base and use our rule. So for example, x squared and x to the 1st, x being the base, they have the same base. So 2 plus 1 is x to the 3rd. Then we have y cubed and y to the 4th. Those have the same base. Y cubed times y to the 4th will add the exponents according to our rule and get y to the 7th. And then finally, z to the 1st times z to the 1st will add the exponents. 1 plus 1 is z to the 2nd. And finally, number 5 will do the same thing. Anything that has the same base, we're okay to multiply them together. So m to the 3rd times m to the 10th will add the exponents according to our rule and get m to the 13th. N to the 4th and n to the 4th have the same base, the base being n. So we'll add the exponents. 4 plus 4 gives us n to the 8th. And finally we have p to the 1st. No similar base, so it just stays p to the 1st.